Okay, here is solutions to perfect problem 1. Kind of ridiculous problem, but anyways, let's do it. Okay, I think the easiest way to attack this problem is to kind of break it up into chunks, because it's a little bit overwhelming if you look at it all at once. So maybe I'll first try to simplify what I've circled in red here. Maybe I can do that over here. So what I have is 1 over x plus 1 minus 1 over 2x minus 1. So if I want to subtract these rational expressions, I have to find a least common denominator. Neither of these will factor, so in this case, my least common denominator is just x plus 1 times 2x minus 1. So in order to make both of these have the same denominator, I'll have to multiply this guy by 2x minus 1 over 2x minus 1. And I'll have to multiply this guy, this 1 over 2x minus 1, by x plus 1 over x plus 1. And now what I have is a common denominator. Now I have 2x minus 1 times x plus 1 in both of these. So I can write the whole thing over that. And the whole thing is I have 2x minus 1 over here, because 2x minus 1 times 1 is just 2x minus 1. And from that I want to subtract, I have x plus 1 over here, because 1 times x plus 1 is x plus 1. So taking this a step further, I have 2x minus 1 minus x minus 1 divided by 2x minus 1, x plus 1. And if you combine like terms up top, 2x minus x is just x. Minus 1 is minus 2. Okay, so what's in red is this. On to the next. All this mess down here in blue. Let's try to simplify. To simplify that, we'll have to figure out what the least common denominator is, and to figure out what the least common denominator is, we'll have to factor 6x squared plus 17x plus 11. So maybe we'll do that first. Factor 6x squared plus 17x plus 11. To do this, we need to find two numbers that multiply to 66, 6 times 11, and add to 17. And those two numbers are 6 and 11. 6 times 11 is 66, 6 plus 11 is 17. So what we can then do is replace the 17x with 6x plus 11x. And now what we have are 4 terms instead of 3, and we'll be able to use factoring by grouping. So from these first two, the greatest common factor is 6x. You're left with x plus 1. In order to be left with x plus 1 over here, we'll have to factor out an 11. So we now have two terms that both have an x plus 1 in them. And if you factor out that x plus 1, you're left with 6x plus 11. So this mess here factors to x plus 1 times 6x plus 11. So what we can see is, let's see, maybe I can write this all at once. I have 2 over x plus 1, and from that I want to subtract 11 over 6x plus 11. And from that I want to subtract 9 over, I just factored that out to be x plus 1 times 6x plus 11. What you might notice here is we have a least common denominator of just x plus 1 times 6x plus 11. What I'm saying is we could make all three of these have the same common denominator, the same least common denominator, if I just multiplied this guy by 6x plus 11 over 6x plus 11. And this guy here by x plus 1 over x plus 1. I have to multiply these things on the top and the bottom so I don't change the value of anything. But what I now have is 2 times 6x plus 11 is 12x plus 22. And from that I want to subtract 11 times x plus 1 is 11 plus 11x plus 11. And from that I want to subtract 9. And I can write that all over my least common denominator, which is x plus 1 times 6x plus 11. So now if I distribute this negative sign through and collect like terms, I'll have 12x minus 11x, which is just x. And then I'll have 22 minus 11 is 11, minus 9 more leaves me with 2. So I get x plus 2 divided by x plus 1 over 6x plus 11. So now what I have managed to do is I figured out what this in red is equal to and what this in blue is equal to. So I can divide one by the other and I'll figure out what this entire thing is equal to. So maybe I'll circle that entire part in green. And then in green somewhere, I don't know, over here maybe, I can do that division. So down here I'll take care of the green. The green is the red divided by the blue. This is the red. X minus 2 divided by 2x minus 1 times x plus 1. And what I want to do is divide that by the blue, which is this guy, x plus 2 divided by x plus 1 times 6x plus 11. And I can do that. I can divide rational expressions. It's a lot like multiplying rational expressions, except you multiply by the reciprocal of the denominator. What I'm trying to say is we got x minus 2 over 2x minus 1 times x plus 1. And we can multiply that by x plus 1, 6x plus 11, divided by x plus 2. And in this, maybe you'll notice that this x plus 1 here and this x plus 1 cancel out. So really, in green, what I'm left with is x minus 2 times 6x plus 11 divided by 2x minus 1 times x plus 2. So what I've now done is simplified this whole thing in green. So I'm just one step away. All I got to do is add to my green answer, these last two terms. So maybe I circle the entire thing in black, even though at this point it's getting a little ridiculous to circle stuff because it probably all blends together. But down in black on the bottom of the page, I'll take my green answer, which is all this stuff, and add this guy and add this guy. So that's what I'm going to do somewhere. Maybe get squeezed by here. Let's do it down here. Okay, so start with our green answer, which was x minus 2 times 6x plus 11 divided by 2x minus 1 times x plus 2. And to that we want to add, remember that's just this green stuff, 5 over x plus 2. And to that, we want to add 21 plus this mess. Sure, I'll just write it twice. 21 divided by whatever 2x squared plus 3x minus 2 is equal to. So if we're going to find a least common denominator and put these all together, we better factor this guy out. So we're kind of repeating steps. Factor 2x squared plus 3x minus 2. Have we done that yet? I don't believe we've done that yet. So let's do it now. Factor this out. Leading coefficient's not a 1, so we need to find two numbers that multiply to negative 4 and add to positive 3. The negative 4 being this 2 times this negative 2. The two numbers that do that are, what, 4 and negative 1? So what we can do is replace 3x with 4x minus 1x. And now we have 4 terms and we can factor by grouping. Greatest common factor from the first two is 2x, and that leaves you with x plus 2. Greatest common factor from the next two is negative 1. That leaves you with x plus 2. Now we have two terms that both have an x plus 2 in them, so we can factor that out and be left with 2x minus 1. So what I'm saying is this thing right here, instead of thinking about it as 21 over 2x squared plus 3x minus 2, we can think about it as 21 over x plus 2 times 2x minus 1. And the advantage of thinking about it in that form is we can kind of see the least common denominator. This is the exact same as this, and this is just missing the 2x minus 1. So our least common denominator is going to be x plus 2 times 2x minus 1. So this first term is already good. Okay, let's see here. We already have 2x minus 1 times x plus 2. On the top here, I could just copy this, but we're going to want to get rid of those parentheses. So maybe down in the corner, if I have any corners left, I'll multiply those top two out. I'll multiply x minus 2 times 6x plus 11. And if you do that, if you use FOIL or our box method, you get 12, you get 6. Did I write that right? Yeah, x minus 2. You get 6x squared minus 12x plus 11x minus 22. Which if you combine like terms, it's 6x squared minus x minus 22. So this is 6x squared minus x minus 22. And then in here, I had 5 over x plus 2, but I want the denominator to be x plus 2 times 2x minus 1. So I'm going to multiply this by 2x minus 1 over 2x minus 1. And now I have the same least common denominator in all three of these terms. So I can write all of it divided by whatever that least common denominator is, 2x minus 1, x plus 2. And what do I end up with up top? Let's see, I got 6x squared minus x minus 22 plus 5 times 2x is 10x. 5 times negative 1 is negative 5. And then I have this 21 at the end. And if you combine like terms, you got a 6x squared. Let's see, I got minus 1x plus 10x. That gives me plus 9x. Got minus 22 minus 5 is minus 27. Plus 21 would be minus 6. Divided by 2x minus 1, x plus 2. And I'm so close to being done. All I have to do is factor the top here and hope that I can cancel it out with some stuff down on the bottom. Turns out you can. First note that you have a greatest common factor of 3. If you pull out that 3, you're left with 2x squared minus 3x minus 2 plus 3x, sorry. Pull out a 3 from 9x, you're left with plus 3x. And then on the bottom, we got 2x minus 1 over x plus 2. So now we just have to factor what's in the parentheses here. The bottom will stay the same, 2x minus 1, x plus 2. And this 3 will stay the same. We just need to factor this guy out. We could, but we've already done it. Right? 2x squared plus 3x minus 2, we already figured out was just x plus 2 times 2x minus 1. So we've already factored this, no point repeating it. And now you're finally to the step where you can cancel some stuff out. We got an x plus 2 here and an x plus 2 here, 2x minus 1 here and a 2x minus 1 here. And when all the dust settles, that ridiculous mess of a problem is just equal to the number 3. And 3 is the number that Babe Ruth wore, although you can't even see that anymore. That is finally the end of this horrible problem that I made way too difficult. Sorry.